Hello, in this video I will talk about how to define variables within Google Earth Engine and how to work with data within the Google Earth Engine cloud computing platform. First, let's create a new repository for this course. For example, workshop poverty. Creating a repository named workshop poverty, which is by now empty because we haven't saved any script here. Now let's define a variable in GEE similar to other platforms. We can define different variables, but consider if it's in client side or server side. Variable, for example, x equates 1, and let's save it as a script in workshop poverty named 1 underline basics. Okay, the script is saved here within this repository, and let's print it. Print x. We run it, and here 1, and we can say print, for example, defining the name as string, print x. Okay, x equates 1. But consider that x is just defined within your browser. It's at client side. So let's say client side versus server side. Variable x underline, for example, x2 equates ee dot number 1, and print x2, and let's put its name as a string x2 and the value of x2. Okay, before running this script, consider that print is the function that shows the variable here at the console. But if the variable is just defined at the client side, it will quickly be printed here. But if it's defined at the server side, it should be fetched from the server to the client side and then printed here. So consider that printing x2 will last longer than x. So we are running this script. For some seconds, it was circling and fetching data from the server side. So consider it's different to be at the client side or server side. This is what I'm talking about, that documents, this tab is very important. Whatever we are going to define should be available here. For example, we are going to define a number, for example, simple number 1. It should be used using EE number. We can use EE number and the real number value and constructs a new number, but at the server side, not at the client side. Let's continue. Variable y equates x plus 2, and print y and the value of y. And let's run it. x1, y3. Okay, and x2 is 1. Let's do the similar operation at the server side. Variable y2 equates x2 plus 2. And let's print y2 and the value of y2. Running this script. Let's take a look what we have for y2. It's e number 1 and 2, because this simple addition is for the client side, not at the server side. You are adding a client side, a server side variable with a client side variable, and it doesn't work. So you can get the correct value. And besides, consider that the simple addition, using this cross value, is not defined by the server side operation. For adding two server side numbers, we have the add operation as the first value to the second. For example, here, instead of this one, we comment it. It doesn't work. We can use this one. y2 equate x2 dot add 2. And running this one. Now it works. y2 equates 3. This is very important when using Google Earth Engine, because we are programming in JavaScript, but consider that simple JavaScript, pure JavaScript, doesn't work. The comments work, but the comments should be converted from the client side to the server side. So this is very important when you start working with Google Earth Engine platform. Similar to other programming languages, we have different variables. We have a string, we have integer, we have float, we have double, we have similar number of different number of data types. But if you are interested in, you can just take a look at itself. But now I'm going to start working with real data. Let's save it as DHS points. Okay, removing this part. Okay, we have this CSV file. This is the DHS file. For each survey we have different values. If it's in rural area, the months of survey, the country code, the country, and also what we are interested in is IWI value, the International Wealth Index. And the points should be geolocated, and this extra generated column is the geolocation. For each one we have the type of point and coordinates and longitude and latitude information. So we are just uploading this file into the Google Earth Engine. Here from assets, new, we are going to upload a new CSV file, selecting the file and uploading DHS sim points. Uploading and also exporting, importing and exporting are Google Earth Engine tasks. So a new task is submitted to the server, and we are waiting to be completed. It will be completed very fast because it's just a CSV file, maybe a minute or less than a minute. Okay, as I said, it completed less than a minute, and let's take a look at what is imported. View assets. Its name is DHS sim points. It's available here in my assets, but as there are too many assets here, let's import it from here. Importing, and here DHS sim points is imported here. Let's name it as DHS and printing it, print DHS, because these DHS points includes 64,000 points. It cannot be printed here at console, because at consoles, I mean, there is a limitation for 5,000 elements, so we can limit it just for printing. Print DHS dot limit, for example, to 20. Run. Here, DHS is a feature collection. Feature collection means a collection of features. So each feature is one DHS server points. We have 64,000 features. A collection of these features is the feature collection. I'm just talking a different type of data within the Google Earth engine. I mean feature and feature collection. So this feature collection, that we printed has 20 features. And each feature is one DHS survey point. So let's take a look at these specifications. Each of them has a geometry, latitude and longitude, and has some properties, cluster ID, IWA values, the country code, month, if it's in rural area or urban area, and the year of surveying. So this is what we have, and we printed it at the console. We have another command, besides the print command that sends the data here at our console. We have map.add_layer. Map means we are working with this map area, and we are adding a layer to this map area. We are adding the layer, for example, the DHS, all DHS points. Map_add_layer DHS. Running this algorithm, and DHS points are added to the Africa continent area. Okay, but this is all DHS points. All countries, all years. If we take a look at to this asset, we have different features, and consider that we can filter out the data using different features. For example, we are interested to see what countries are available or what years are available. So let's comment this one and print. We are going to print DHS and taking a look what countries are available within DHS points. Dot aggregate histogram, and the feature that we are looking at is a country. Okay, saving and running this script. Okay, these countries are available: Angola, Benin, Burkina Faso, Burundi, Cameroon, and this is the list that we have. And let's take a look at the year print. Let's accelerate the procedure using copying and printing the year. Print. Okay, running. These years are available from 1992 to 2090s. So we have this data. But consider, DHS is a feature collection variable. So in the documents, we are going to a EE feature collection, and we are applying the aggregate histogram command into a feature collection. So aggregate histogram should be available within the Google Earth Engine documents. On the other hand, we cannot use this comment at the server side because DHS is now at the server side. All assets and all saved assets are at the server side. So let's take a look. We have aggregate histogram comment here, and if we take a look, it aggregates over a given property of the object in a collection, calculating a histogram of the selected property. It gets the feature collection as the input and the property as the string value, and returns the dictionary. So here we have the dictionary as the output, I mean the key and the value. Key are different countries and the value is the histogram. I mean we have about 1000 server points of Angola in different years, but totally we have this 1000 server points. So this is useful for filtering out the DHS points. For example, variable, we are going to take a look at, for example, Burundi. Variable DHS Burundi equates DHS, we are going to filtering it to the samples just in Burundi. Okay, so we are applying a filter command to a feature collection. So filter should be available within the feature collection category. Let's take a look. Okay, here we have the filter. Apply a filter to this collection. We apply the filter to a feature collection, and here we define a filter. So to define a filter, we go to EE filter. What filters are available? For example, here we are interested in EE filter equate because we are interested in filters in which the country equates Burundi. For example, we have different filters. For example, filter date, filter contains, greater than, lower than, and all filters that are available here. EE filter equates, country equates. Let's take a look. Burundi is available here and it has 1200 server points. Okay, save and run the script. Let's move this map layer to the upper part. Before adding layer the DHS Burundi points, I'm interested in talking more about map and layer options. Map and layer we have here, here we have map, in map we have map.add layer, and for add layer we have different options. The first one is EE object. It could be feature collection, feature image collection. So we are adding an Earth engine object to the map. Besides, we have some visualization parameters. We can add a name for the layer. Here we have layer 1, layer 2, but we can add the name of the layer, and shown can be false or true. I mean, by default, should it be shown or not? So here, no visualization we are going to define, but the name of DHS, and I'm interested to be false. I'm going to add DHS Burundi points into a layer. Okay, save and running the script. Let's comment it, not too interested in printing it multiple times. Okay, we have DHS and DHS Burundi. DHS are all Africa contain DHS points. Besides, we have DHS Burundi, which are just Burundi points because we filter out other countries. Okay, but within the Burundi, I'm also interested DHS points of Burundi of a specific year. So let's do the print. Another one, print DHS Burundi variable and aggregate histogram its year. I mean, what years are available within DHS Burundi points. Running it. Within the Burundi, we have data from 2010 to 2070. Let's select one date and showing the image for this date. Okay. Variable DHS Burundi, for example 2016, equates DHS Burundi, and let's filter it again. That filtering, we are going to select year as 2016 and consider, let's move back to the features. Here, let's consider, for example, for the country, it's a string. The name of the country is a string, but for the year, it's integer. This is why for the country, we use as a string variable, but for the year, we use an integer variable. Okay. Map a layer DHS Burundi in 2016. Save and run the algorithm. All DHS points, DHS in Burundi, and DHS in Burundi for 2016. Okay. Let's, for example, DHS Burundi 2016, let's use the inspector value and click on one of these points here. DHS Burundi 2016, it just have one feature and the feature value is here, IWI is about 13. So we can use inspector to, just a visual inspection to a manual inspection. Okay, let's move to the next part. We selected a region of interest, Burundi. For Burundi, we filter out also the year, for example, for 2016. Now I'm interested in loading some data, some remote sensing data for this area. Okay, let's save it as a new script, DHS, and for example Landsat date. Okay, let's simplify the code and remove non-required ones. Variable DHS Burundi 2016 contains 2 filters. Okay, variable DHS Burundi 2016 is the DHS value, filtering by Burundi and filtering by year, and then we have our interested target date. Okay, now we are interested in Landsat data. For example, let's take a look. Moving back to data catalog, Landsat data. I'm just going to cheat the code from Landsat 8 surface reflectance data. We have the code here, and we can copy the code to our script. Okay. Variable dataset, EE image collection, our desired Landsat 8. I'm not going to use all this data, not this center, not this visualization. Consider also this data can be used as an import variable. For example, here we can write that Landsat 8 surface reflectance. Okay, here we can also import the data. The data is imported here and we can use the data. However, dataset, I mean Landsat 8 collection equate image collection, which can be here or at the top. We also, if we're interested to move here at the imports section, we can also use this one. I mean, filtering, commenting this one. It will be, I mean, highlighted that can be converted to an import record. And if we convert it, it will be come here as an import record. Okay. But consider this Landsat collection is all Landsat 8 image tiles that covers all layers and in global scale. It includes all data, but we are interested in 2016 data and in our region of interest. So we should filter out non-usable image tiles. Variable LH collection Landsat 8 collection equates Landsat 8 collection filter equates Landsat 8 collection. Okay, dot. Landsat 8 is an image collection. Image collection is the collection of images. I mean, it includes all image tiles, similar to feature collection that includes different kind of features. image collection includes different Landsat 8 images. So here we have, at the top level we have collections, image collection, feature collection, and then images, and then pixel values. So let's filter date. We're applying the filter date into an image collection. So filter date should be available within image collection comments. Besides, we can search the command here. For example, for filter date, we have the filter date command in EE image collection. Filter date, shortcuts to filter a collection by a date range, the start and end, maybe dates, number, etc. And this is important. Consider that the start date is inclusive and the end date is exclusive. So if we write, for example, for 2016, the first date and the first month and the first date, the first date of 2016 is included, and if we select the end date to 2017, the first month and the first date of 2017 is not included, it's excluded. So this filter date just includes all images during 2016, and we are interested to filter bounds. For filter bounds, we can add different variables. We can add feature collection, and also geometry. Here we have different geometry tools. For example, we can write a rectangle, we can draw a polygon, we can draw a line, we can add some points, and we can use this geometry as filter bounds. It means the images that contains these points should be selected. But here we are not interested to use this manual definition, because we have some DHS points in Burundi that we're interested to include these points, and these points are also georeference. So we filter bounds using DHS Burundi 2016. Map that, let's print it. Print Landsat 8 collection filter. Here at the console, for 2016, that covers the Burundi, we have 140 image tiles. The first image is from 4th in January, and the last image is captured as 26 in November. Okay. But consider it's image collection. Image collection means, as I said, collection of all images. It should be aggregated to a single image. So we can use, for example, a median that calculates, pixel-based median values. Let's not ruin the image collection. Variable Landsat 8 image equates Landsat 8 dot median, and let's print this one, Landsat 8 image, and running this one. You see, it's image collection and it's an image. with different bands. Okay. Now we are going to add layer this image into our region of interest. Landsat 8 image will be added, running this algorithm, and now we have Landsat 8 image here. For the visualization of the optical remote sensing data, we typically use RGB bands, I mean red, green, and blue bands, and in this image collection, red, green, and blue bands are B4, B3, and B2 for red, green, and blue. So for visualization, we select B4, B3, and B2, and a custom visualization applying, and this is what we have. You can see it's not a very good median image. There are many tiles, we have some cloudy areas, so it's not what you are interested in. It's not too bad, but it's not an ideal image input. So let's take a look at Landsat 8 collection. For Landsat 8 collection, besides the bands that I talked about, we have different bands, optical bands. For example, we have near infrared band, short wave infrared bands, thermal bands. We also have image properties. It means each image tile has some properties. And one of the most useful properties is cloud cover land. Cloud cover land means for each image tile, the USGS by its own algorithm calculated the percentage of cloud cover in that area. So we can filter out the cloudy pixels. We can filter out the cloudy tiles. So it will improve our image aggregation. So let's do it. Dot filter EE filter, and now lower than, because we are interested in the pixels in image tiles in which cloud cover land are less than a definite value. For example, cloud cover land less than 20%. Okay, save and run. Landsat 8 image, visualization, B4, B3, B2, custom visualization, and this is much more better than the previous one. In Burundi. Okay, we have import button. We can import our visualization to the import section. So here we have the visualization, the name of bands, minimum, maximum, and okay, we are copying the image visualization parameters here to image visualization parameter, and let's comment this one. I mean, I'm just going to change the showing how to visualize, I mean the level of visualization. Save, and you see here we can see DHS Burundi points, but they are at the background. I'm just moving the background foreground for a better visualization. I'm running the algorithm, running the script. Here we have Landsat 8 image, and here we have DHS Burundi. We can use inspector click at a point, and at this point these are Landsat 8 image bands, and also you can see there are three type of objects. The first one is points. It's line to zoom level scale. It's not very important. Also, without any layers, we can see this one. We have pixel values. Pixel values here. We added an image, Landsat 8 image, and if we use inspector, we can see the pixel value of Landsat 8 images. All Landsat 8 bands. Besides, we have objects. Objects can be feature collection, whatever that is not the type of pixel. For example, here for the Landsat 8, it's an image, and you can see the image pixel, the pixel value here. But besides, we have DHS Burundi value, and DHS Burundi value has a property, and its IWL value is about 20. However, if we click somewhere that we don't have any DHS points, for example here, we have Landsat 8 image bands, and we have Landsat 8 that says that the object is available, but the value is here at the pixel. But for DHS Burundi, no matches at clicked point, because here there is no DHS point. So this is the principle of working with different data within the Google Earth engine.